Okay, so welcome all for our 10th Architecture Weekly and GitHub sponsor webinar. And today we'll be discussing the Postgres superpowers in practice. So let's maybe start why we are here to discuss those Postgres superpowers. Because from what I notice, especially in the .NET community, Postgres seems to be like a cheap alternative for more advanced databases like MS SQL or even Oracle. I hope that in other environments that's much less opinion, much less popular opinion, but undeniable one of the benefits of using Postgres is that is open sourced, so we can use it for free. And most of the cloud providers already provide us that option to use it through the managed services. But that's not all. That's only beginning of the story and the first chapter of why people select Postgres. And we will be discussing what other options Postgres can provide to us. To make it more real, I selected the fleet management business domain to show how Postgres and its capabilities can help us to streamline and make our business development much more effective. I should probably invite my wife because she's an expert in fleet management. She was and she is actually working in that industry, but you have only me, so bear with me. And this will be highly practical because that's what I prefer to do, as always, to just show me the code. So let's start with maybe defining the initial table structure for our scenario. So the base of fleet management and the most important aspect of fleet management is managing the car trips. So I'm sure that in each country, the laws how to provide the full documentation about the fleet management in company is quite complicated. But we will be using a bit simplified scenario, but I hope that this will give you enough business context and potential how you can expand it. So car trip is of course something that we are going, for example, to our client, to other company department, or maybe to some conference or any other business trip that we would like to do with our business car. So it should at least contain information of where we started, where did we go, how many kilometers did we make, and of course, how much liters or gallons, if we are from US, we have used, because that's practically is changing into the money that we spend on the specific trip. So in this table, there is nothing specific around Postgres besides maybe types name. It's a simple table, but that's more or less how it will look like. So there is nothing scary here. However, if we have a look on how this might evolve, then it might start to be a bit more scary. So for example, in the company that my wife is working, they have like 3,000 of car, and that's probably not even the biggest amount that you can have in the company. So you can imagine how many trips daily, because this company is based on moving from one place to another, how many trips you will need to record. And of course, relational databases are pretty good on keeping a lot of data, so even millions of data wouldn't be an issue. But typically in this industry, besides the like a summary that we have here in this table, then we will have many other data. For example, it's quite common to keep the recordings of the specific GPS coordination that were registered and showing that online. So for example, being able to show the specific trip on Google Maps or any other maps to know precisely where it is going. So if we add to these trips and if we multiply that with the GPS measurement information about drivers, then it might appear that the amount of data that we will be keeping will be much more severe. So we will focus here today on the trips table, so on the summary, but keep in mind that this is just a tip on the iceberg of our typically star schema because we are using relational database. So how can we deal with that? So Postgres has the maximum size of our database equal to I think 32 terabytes, which might sound quite big, but I already had the project when this wasn't enough. Plus, this is all the data that we have in our database. It's not like a single table. So Postgres give us option to expand this maximum size and also make the keeping our data much more efficient. So that option is called partitioning. And of course, some other relational databases also have that option, but let's have a look on what Postgres give us. So we can have a similar definition as we had before, but now we have an additional keywords used, which is claiming that we are partitioning this data by range. And in general, that's not that's the most common way of partitioning. So we might say that depending on the value of our data, each partition will be kept in other storage location. So if we like to define partitions, then we could run following function. So defining a specific date range. So for example, from 1st of January 2023 up until the 31st of December 2023, we will be setting partition for each of month. So see here in while loop, we are just starting a new, so we are setting up new partition, which is equal by, we will be grouping our data by month. So of course, we don't need to run it in a for each loop. We don't need to have a specific procedure, but what we still need to do in partitioning is to run this specific script, which will tell us that we are partitioning this specific table that we defined here and setting the specific range of values, because Postgres internally not yet is using ChatGPT and it cannot guess what will be our expected partition. So is it more or less clear, the idea, or should I expand on that? So I don't see any comments. So I assume that silence means that it's okay. Thanks, Camille. It's clear. So we not only have the partition by range. Postgres give us more option, and with each Postgres release, we are getting that much more sophisticated. So we can also, for example, partition by hash value. So provide a specific hash for our data. And so it's a quite similar or partitioning, for example, in strategies in Kafka or messaging systems. And we can also, by the specific values, we can provide such partition. So it's much more sophisticated than by range, but it's still quite tedious because Postgres won't create these partitions in advance. So for example, if we try to add new record and we don't have this partition set up, then it will append it to the default partition, and we cannot easily move and repartition data. So it is quite tedious, but we will see how could we potentially improve that. So let's try to execute that. Okay, it seems that I think it has been run. And let's double check that in our database. Let's refresh it. So we have our trips. It doesn't have any data, but if we have a look, then I'm using Rider, but that should be also visible in any other IDEs. Then we can see clearly that it created a multiple, so 12, 11, I think that I've made a small mistake, 11 partitions, and each of these partition has this specific set of columns. And that's actually super helpful because let's close it. That's pretty helpful because if we now run following query, then we don't need to specify any partition, but Postgres will automatically join or get into the specific partition. And the tricky part about the partitioning, it's not like with everything, it has pros and cons. The pros are that if we have a lot of data, then we can break it and keep this data in a separate storage location. But then if we try to get data between partitions, then it will be slower. So what we should always do is to include this specific partition column in our query, because then we should be sure that we are touching a single partitions. Of course, it can be still usable, but it won't be extremely fast if we will try to get the data from multiple partitions. So there are some other toolings, like for example, Partman, which is plugin, and we will be discussing with plugins in a minute, that will automatically generate partitions and manage them. But I would like to show you some potential alternative into that. So to make it more smoother. So let's try to use another SQL statement. So let's delete our table and recreate this initial one. And besides that, let's call a following query. So this is the first one, and this is the other one. See, now we have it. And let me explain briefly what did I just made. So Postgres has even I will explain it after I finish this extensions. So create extension is setting up and is adding a new plugin into our Postgres database, because Postgres is quite special in other comparing to other databases, because Postgres engine assumes and was built to allow like open extensions. So in this case, I'm using extension like Timescale DB, and Timescale DB provides us some capabilities, like when we install Timescale DB, then we are getting, for example, some another function. This is a regular function. See, if I go to definition, then it will show me. It's like a create function. So we are extending capabilities of the vanilla Postgres installation. And we can, for example, define something that is called like extremely sophisticated hyper table. And hyper table in Timescale DB is a table that will be automatically partitioned by the specific column. So we are saying that we will be, for this particular table, so trips, we will be partitioning it by the trip time. And Timescale DB is a plugin that was specifically created to keep and efficiently query the time series data. So for example, like here, because we are having a lot of trips, so a lot of data that will be partitioned by the specific trip time. So the trip time for the vehicle ID is also a primary key. And let's get back for a moment to our create extension. We can also, Postgres allow us and provide an automated way. This is just an SQL query, an automated way to also, for example, upgrade to the other version of our plugin. And plugins internally should be defined in a way that should be easily versioned. It should be provide also scripts like the installation script, the uninstallation script. So it's quite easy to manage them. Of course, the other the small issue that we might have is that those plugins will potentially need to be installed on our server where we are using our Postgres database, because they may require some additional libraries that the vanilla Postgres doesn't have. But that shouldn't be an option, because most of the cloud native solutions like Azure, RDS, Amazon, or Google already have a predefined set of the most popular plugins that they allow to just install with a single click. So regarding Timescale DB, it's available in Azure. For unknown reason, it's not available out of the box for the AWS, for AWS RDS. I'm not sure about Google, but you can always install and run Postgres as from on the container, another type of solution. So extensions give us possibility to, for example, get custom data types, user-defined functions. So this is a user-defined function. It allows to have like a different operators, aggregators. We will see that in a moment. And also expand some indexing capabilities, triggers, extension scripts, etc. So Timescale DB simplifies hugely the usage around the time-based data. And also internally, it's built on top of regular partitioning, Postgres partitioning, and it will automatically create the partitions for us, although they will be a bit specific, so they won't be visible easily in our IDE. Let's have a look. See, partitions disappeared because then they are kinda internal implementation of Timescale DB. So we have a question from Ivan. If you have table with huge amount of data, is it possible to partition it? Yes, it's possible, but you might need, I think that you may need to move the current data into the specific partition, or you will need to create another table and define partitions for it, and then migrate data from old table to the new one. And then when you will be inserting records to this new table, then they will be automatically partitioned. So you can just use regular inserts and Postgres will internally handle that for you. So for example, if we have the partitioning strategy defined by Timescale DB, then see, I'm not using any specific partition syntax. From the insert perspective, we won't know where exactly those records will land. And when we query this data, then it can also provide us the unified information and unified data across all partitions. But of course, as I said, better to provide this additional option and only query the specific partition. That will make our querying much more efficient. So I hope even that answers your question. If not, then feel free to ask the follow-up and I will try to make it clearer. So yeah, having this information and internally distributed through the partitions, so this so-called hypertable, we can define some basic reporting and some basic summaries, like for example, average distance per trip, per driver, or the fuel efficiency. So potentially how much fuel this particular person is using per kilometer. So, or how many kilometers does it go through the specific liter usage. And this is quite important because, as we know, a lot of people are trying to cheat and they are going, for example, for their personal trips and are not putting information in the trip registry. And then, of course, they are not buying fuel from their own pocket, but they are trying to use and pay from and use the fuel that they should be using for a business trip. So fuel efficiency and also other similar stuff is quite like the basic strategy, or trying to catch some discrepancies and potentially the mishaps and wrong values and wrong usage. Of course, so potentially to either trying to find cheaters, or it might not be about cheaters, but some loosey person, because in our law in Poland, and I guess that in other countries it's similar, it's quite important to put all the information about the trips. And this is quite tedious, this is quite annoying. So a lot of people are forgetting to register their trips. And if they didn't register trips, then it may appear that they used much more fuel than expected. So this could give some tooling for our care fleet management department to maybe ping them and ask them to maybe provide those information about the trips they made. So it's not only about potentially punishing people, but also making that like helpful for them. So yeah, but if we see that, then we already could see that I mentioned that we might have a lot of data, and such queries made on the fly are not always the most optimal way on handling reporting. We will like probably to not calculate those things on the fly, especially that those measurements may be much more sophisticated. And potential option to handle that is to set up the materialized view. Let me just clear it. So materialized view is a feature that is also available with our native vanilla Postgres and also in other databases. So what it means that all of the queries and all the data that is filtered by the specific query condition and the specific aggregations will be stored technically as data, like data put into some storage location. So we can think about materialized view as some sort of read-only table. And what we are doing here is that we are now trying to find all the at first, we would like to just get information from the specific time. So for example, last month. So we are interested in a specific last month because we can assume that the old month contains probably just read-only data and no one will be updating it. And we would like to have aggregation per a single day, and time bucket is another function that was added by the Timescale DB. So what it does, it's trying to do a bucket analysis. So it's grouping the trip time in a specific interval. So for example, 1 day. So then we will have an averages per a single day, and then getting the fuel efficiency average. And this is the additional syntax that is Timescale DB also adding to us, because materialized views in general in most of the databases are not updated automatically. They are not updated automatically because updating materialized view usually means that we might be potentially updating all of the records that are stored in this materialized view. So this might be resource consuming. So usually we are setting up some schedule or cron job that will be updating this materialized view. So if we are using materialized view, then it's much more performant because we are not doing any calculations on the fly. But on the other hand, it brings some eventual consistency and some additional tooling that we usually need to provide, because we need to run our own cron job, and we also need to update and tell database to refresh the view. And if we are using Postgres with Timescale DB, then we may say that this view will be continuously updated internally by the Timescale DB. And to do that, we also need to define the specific schedule. So continuous aggregate is a function like built in a Timescale DB, and continuous aggregate will be refreshing the specified materialized view. So see, this is the view that we defined here. Then it will start from the 3 days ago. We may change that. And this is the last time that it should be refreshing. So it should start like from 3 days ago up to 1 second ago. And we can define how often this view should be refreshed. So maybe 1 day is enough. Maybe we would like to do it 1 hour, etc. it doesn't it should be aligned with our specific business case. And interval is also interesting because this is an example of the custom type that is defined by the plugin. So in this case, Timescale DB. Unfortunately, I cannot go to definition, but maybe let's try to hover. Unfortunately not. So what it's saying is that we are using some interval, and this interval will make the automatic convention for us. So if we'd like to define our own types and build, for example, our own plugin, then inside of it, what we could do, maybe let's show it here. Right? So for example, we would like to provide a new type. So it's a domain type, domain specific type. And for example, email address. And we may say that email address will use the vanilla Postgres varchar internally, and we will add some additional constraint for the specific type. So for example, the mask that we will allow only emails, so strings, varchars that are fulfilling the email regexp. And then when we install our plugin and create the specific type, we don't even need to oops, I started. So we don't need to even install the plugin. We might just do it. Let me stop it. We might run it like that. And it should create the specific type. And then if we define the user table, then it should already contain it. Let me try to see if that worked. See, we have a users table, and user table has our email address type. So it's extremely simple to define our own typing. Of course, with the great power comes great responsibility, so we should be really careful and not put too much of the business logic in our database, but in many cases, it might be super helpful. And for example, it gives us powerful options to additional plugins, because here we can easily define our intervals, so provide a specific format of our interval that will be much easier to read and much easier to define. So again, we defined the materialized view, and materialized view will be keeping all the information, aggregated information from our trips table, and we can define this continuous aggregate policy. And let's have a look if we have such view and if it contain any data. Yes, we have it, and see, it automatically aggregated all the information that we need from the specific period of time. So simple as that. And interesting part about the continuous aggregates in Timescale DB is that Timescale DB internally uses and provides its own capabilities, cron capabilities to Postgres. So it will be running internally on the database server the cron job. So we don't need to define external cron like on external services, external containers that will be calling database continuously to do some actions. And Timescale DB is of course not the only way. There is also pgcron, which provides similar capabilities. So is it clear about the materialized views and continuous aggregations and some custom type, or should I expand on that more? Feel free to to ask any questions in the meantime. I will be having a look on the chat, or you can also use voice if you prefer. So no questions for now. So let's go further. We need to go deeper, and let's try to understand how this cron internally works, and maybe let's try to have a look on the other capabilities. And we have a question from Ivan. Is there a limit how many partitions you can have per table? Yes, there are limits, and it depends highly on the Postgres version. And in each version, they are increasing this limit. I think that I don't remember the exact number, but it's really huge. I think that it's in thousands. I once created for 512 partitions and it was working fine. I think that the maximum number in the recent version is like some 10,000s or even more. So, of course, one thing that I forgot. What is also super special about the Postgres partitions is that they are cutting the operations need to manage them, because we can, by a single command, we can attach or detach this partition. So there is a attach partition command and detach, and what it will do is that it will either add this partition to the current Postgres installation or remove it. So it's super easy to, for example, archive the old data, and if it appears that we need more, then we can bring it back. So I also encourage to use some archiving strategies in general in databases, and Postgres partitions are making that much easier. It's just a single command. Okay, so let's define some other table. So we won't be just doing a single table strategy. And here I just defined a table for fuel efficiency alerts. So as I mentioned, we might want to define some alerting and look on those fuel efficiency information on a constant basis, to either trying to catch like a do fraud detection, or maybe just trying to be proactive and ask users whether they didn't forget to add a specific trip. So this table contains information when the trip started and finished, the specific vehicle ID, and the fuel efficiency. So this number that is the most interesting for us. So to get and to calculate those fuel efficiency, we could use the following function. And the function is rather simple. So we could define the job ID, some additional config. That's not needed. We will get to that later. But internally, what we are doing is selecting from the materialized view that we had before this vehicle fuel average, and selecting this fuel data that is below average, like a magic number 5. Of course, this is a magic number, like for example, 5 liters per kilometer. So if it goes below 5, then it means that it's possible some fraud or mishap. Of course, in the real life, those calculations would be more sophisticated and involve more factors, but this is just a simplified example to maybe focus on the most interesting stuff. And then we can use this bucket information and select only information from last month. And then this is a syntax that if we find that such record already exists, then we are just updating the already existing alert. I'm doing here like a merge because we wouldn't like to have a constant alert about the same information. So we are either inserting new alert or updating it if something has changed. And if it appeared that user provided the missing trip and the fuel efficiency get above this magic factor, then we can delete this the specific data, so it didn't exist in our database. So then this alert will just disappear. So there is nothing like extremely important here besides an example how to calculate this efficiency alerts. But I defined this function to show you how we could potentially, and let me run it, how we can potentially specify and run this built-in cron capabilities. So we can use another function from Timescale DB, which will add job and run this specific function on the continuous basis. So like each second, it will try to generate new alert. So this is something, again, example of if we are using the proper plugins and there is a lot of plugins that we could trust, then we can extremely simplify and shorten our implementation. So let's define this trigger and let's have a look if we have something already generated. We have some below 0. So for the date 6, and let's have a look on the fuel efficiency alerts. So see, we have this we have those two that are below 5, and as 1 second already lasted, then we have already new alerts created by our stored procedures. Yeah, and Ivan suggested that, said that sounds like NPM for databases, and it's almost like that because let me show you a Docker file that I set up. Not this one, sorry. This one. So this is an instruction how to install the Timescale DB. So we need to add a few stuff here to support Timescale DB on server, but there is already a DB app plugin, so plugin for Postgres, where you can use a DB app almost like NPM for databases. I will add this DB app into the materials and on our Discord later on. But yeah, technically that it works like that. So I really believe that's super cool, because that's also how the RDSs, like cloud installations of Postgres, benefit, and they are really giving us possibility to just click on the UI and they will install the plugin on our database. So yeah, I think that this is really extremely powerful. So okay, here we are. So maybe to not make it like a love letter to Timescale DB, because that's not my intention. Let's have a look on some other example of the potentially what Postgres can give us and what other plugins can give us. So we will be discussing the PostGis, and PostGis is a plugin that will allow us to effectively handle the geometric, so geospatial data like locations, trips, etc. But before we get into that, there is a question from Camille. Do you know how they are handling concurrency in jobs? Are they queuing job, or there is possibility to run them in parallel? I think that you can run them in parallel. I'm not sure if you can run the same job in parallel. My guess is that it's because it's scheduled for a specific time, then good question. I'm not sure. I won't be cheating. I will try to check that after the webinar, but that's a good question. I think that it's also highly dependent on the plugin we're using, but my guess is that you can run them in parallel, but the specific job will be run in the defined interval. So I'm not sure if that means that it will be sequential or just run on a specific time. That's something to double check. Good question. So getting back to PostGis. So for example, we can alter our table and add information about the specific root. And root will contain a geometry, and geometry is a type that PostGis is adding to for our needs. So it may contain like the whole route, like multiple points and whole location and whole how did our trip looked like. So having that, we might realize that maybe let me show you to again our trips table. So what I already added the route table, which is geometry, but we also have the start location and then end location, which is currently text. But if we are using PostGis, then maybe we could use points, specific points, instead of like a dummy text to keep information about our route. And if we have a look on the data that I added, is those information look almost like a geo position. So it's a longitude and latitude. I never remember which one is the first and which one is the second, but we have both. That's the most important part. So we could go further and also modify our trips table to maybe keep and put the default information to our route. So for example, we can use the start location and end location, and for the already existing data, we can define a simple route. Of course, it won't be real because it will be just a straight line from the start location to end location, but still it will be like that. So once we have it, then maybe let's try to refresh our data and see. This will be some enigmatic text string because this is how the PostGis is storing that. But what's most important is that it's understandable for PostGis because it's using probably some either text or binary data. And PostGis give us a lot of capabilities. So for example, see, we split the start location by the comma, and then we use that to define point. And point is also, you might guess, another type that is specific format that will be parsed with our st geometry from text. So this will parse the specific text of the specific format and return as the type of the point type. And then when we have those points, then we can draw a straight line, as I mentioned, and then store it as a root data. So as you can see, the storage is also quite concise. So we don't have an extreme amount of data here. It's just some simple binary formatted data. That means that storage of the specific geometry is really efficient and really optimized. And once we have this information from our start location and end location into our root, and all of the rows have already root information, then we can, of course, set the root column as not null. And then we already have, we can make another step. So once we have that, and we have those this all of the information in our rows about the root, then let's do some preparation. Clear the materialized view that have references to our trip table, because we will be doing some serious alters. So what we will be doing is that we will drop existing column, so distance in kilometers, start location, end location, because we don't need those columns anymore. They are redundant because we already have all of the information in our roots column. So just to prove that, then see, this information is what we stored, but as our root column is calculated from start location and end location, then we can use it as the source of truth. So let's get back to our alter. So what we are doing here is that we are removing the old columns, and instead of them, we are adding a similar definition, but we are using a bit different syntax because we are using generated always as, and we are providing some calculation options how to calculate the value for the specific column. And generated always is Postgres, vanilla Postgres way. You don't need any plugins to benefit from that. It's a vanilla Postgres option to have like a calculated columns. If you are in the .NET space, then it's like a getter that is calculating data from other based on some other information. Or if you are in Java, then it's like a function that will be run to calculate the value for the specific column. And we are saying that this will be always generated. And what's more, to make that efficient and not have this calculation made on the fly, then we are saying that we will be storing those information, because we are treating that as some read-only data, and we would like to optimize for querying. And as you see in this calculated column, some just generated column, we can also use functions from plugins, which is super cool, because see, for distance, we are using st-length from PostGis, which will calculate us the length of the specific route. And we can also use start point and end point based on the geometry data and put there into start location and end location. And then when we insert new record into that, then those columns will be automatically generated. And to show you that, let's have a look. See, they are calculated like that. And of course, they are added, let me, at the end. So see, they are recalculated, and we can use them. So Ivan said that in MS SQL, there are already calculated columns, and they are called computed columns. Thanks for that information. And there is another question from Ivan. I had a brief encounter with PG on one short project. One thing that annoyed me back then was that you had to put each column name in double quote. I don't see you doing that. Is it then something that you can actually turn off? Indeed, using columns in the double quotes is a recommended way, but I'm not 100% sure, but you can enforce the strict policy or not. I'm using the default Postgres settings here, and by design, Postgres names are case insensitive. That's why I'm not using big letters here. And if I'd like to use big letters here, then I would need to put them into double quotes, because then Postgres will enforce the case sensitivity. So my guess is that someone enforced to use double quotes to not have those mistakes when someone put a name that contained big letters, and because of that having some bugs. So I in general encourage to not use big letters, capital letters, but just use the default conventions. So like here. But yeah, so what I wanted to show you is that those informations, like those plugins, are really powerful, and they are really going well with the vanilla functionalities. So materialized views, generated columns are something that you have out of the box when you start to using Postgres, but those plugins can enhance it extremely well. So let's try to recreate our materialized view, because I drop it because because our structure has changed. And what's more, we can also refresh manually this continuous aggregate. So let's try to do it. This function is from Timescale DB. So as I mentioned, because we recreated the table, then we also would like to have refreshed information about our averages. So yeah, they are refreshed. And we also would like to have the fuel efficiency alerts. So see, this is changed because our calculation has changed, but it automatically refreshed information. So that automatically worked for us. So, yep, that's like the basic information about the plugins, about the rich ecosystem of Postgres that it has, and some basic capabilities of Postgres. Now we will go to discuss one of my favorite features that Postgres has, so logical replication. But before we go into that, do you have any questions, more questions about plugins, or other features that we already discussed? There are no questions, so let's go further. So I built here in the repository that I will link later on is the simple fleet management application that will be alerting either our fleet management department or our users about some missing trips. So let's have a look what we have in our program. I'm using C# and .NET, but the same stuff can be done in any other technology. So if you are not in a .NET space, precisely the same can be done in Java, in Node.js, etc. All of that is really available, because one of the most important aspects about the Postgres ecosystem is that you have already really mature and ready to use client libraries for all of the popular ecosystems are also those less popular. And besides the main packages, like for example in .NET PostgreSQL, there are already also a lot of plugins that will try to to enhance and provide some alternative solutions. But let's for now stick into the default options. So for example, in .NET, if we are using PostgreSQL, which is the default provider, we can also use some additional plugins. For example, Net Topology Suite, which integrates and allows to register some specific types for our geometry. So all of those types that we defined for PostGis. Besides that, I'm setting up the new web application. I'm defining some course policies because we will be pushing information to our front-end application that will be run on the local host 3000. I'm defining some JSON serialization strategy. So here I'm also adding like a JSON serializer for the PostGis data. So that's also not something that I wrote. That came from the Net Topology Suite plugin. And besides that, what I'm doing is I'm adding the signal R. If you are not in the .NET space, then you can think about signal R as WebSockets on steroids. It's really one of the best implementations, I think, in general, of the push notifications from server to frontend. But if you have any other preferred solution to do push notifications, that's totally fine. So what we will be doing here is that we are defining some, let's say, WebSockets, and we will be pushing through WebSockets and through the Signaler application to the front-end side. And Fleet Management Hub, wrong button. And Fleet Management Hub, what it does, once it receives the fuel efficiency, let's stop it for a moment. Once it receives the fuel efficiency alert, so see, fuel efficiency alert is almost the same like our alerts here. So see vehicle ID, start time, end time, and we are using the decimal for this numeric value. So it will republish alert that was stored in our database. So see here, our goal is to, once we added alerts here, then have it automatically on front end. And before I go to showing you how it is done internally, then let me show you how it will be handled on the front end side. So I will be using the React, doesn't matter. I'm using the Signal R package, which will be listening for the push notifications from our server. This is the URL. And once it gets the fuel efficiency alert raised, then it will have the same fuel efficiency alert, but mapped into the JavaScript. And we will be updating the alerts view, which will show as alerts effect eventually here. So as a simple HTML. Hey, Citelo, no worries. There is no need to apologize for being late. There will be, of course, recording later on, so we can catch up. But it's good that you came now, because this will be like a grand finale of our webinar. So logical replication. And I'm sure that all of you are familiar with the concept of the transaction log, or how it is called in Postgres, write-ahead lock. And write-ahead lock or transaction lock is how databases work internally. So first, we are adding and appending information on each operation that we do, like insert, update, delete. It will be, if databases have internally like a transaction lock, which is append-only structure. And this append-only structure will have new entries on each insert, on each update, etc. So each insert we run, each update, each delete, it will be row by row put into this append-only structure. And then database internally, once the transaction is committed, then it will try to evaluate those data and applied all of those changes to tables, view, materialized view, and other stuff that we defined. And transaction log, for example, in MS SQL, and I think almost all other databases, is an ephemeral structure. So once we committed transaction that made those two inserts and update, then data will disappear from this append-only log. It will be when database feel that it's write time, it can just clean it up. And write-ahead log, which is the name in Postgres of transaction log, by default will do the same. So it will be just keeping those information only when our transactions are active. And after that, probably with some delay, it will just purge those information. But Postgres is one of the rare types of relational databases, or maybe even the only type, that can keep those write-ahead log, so transaction log information continuously and not purge them. So we may tell Postgres, hey, Postgres, don't remove the data that I selected. Like, for example, don't remove information from trips, from alerts table. Just keep all of the information about each insert, each update you made to this specific table. And let's have a look how to achieve that, and what we might be getting out from that. Let's get back to our program. I also defined here the hosted service, so our background worker that will be subscribing to all the changes that we defined that we need. So because Postgres is not removing the information, if we tell Postgres to not remove them, then we might be keeping them and treating this write-ahead log as some sort of like even potentially a queue. Not that I recommend you to do it, but Postgres may send us push notifications, not pull. We don't need to query constantly database, but Postgres may tell us that, hey, I have a new record. And what I'm doing here in this subscription is that we are defining some subscription. Let's have a look on how it is made internally. So subscribe, what it's doing is at first it will try to set up a specific type of connection, because we will be doing some unusual stuff, so it requires some unusual classes. But it's just, jokes aside, it's a PostgreSQL implementation detail. So we are setting up special connection, and then we are defining that we will try to create subscription for the data that we provided through options. And create subscription, we might provide like multiple options. This is the code that I wrote. It's not from any plugin. It's a code that I provided as an example. logical replication connection is from PostgreSQL, the rest is from me. So what I'm doing here is that I provided some option, like, for example, never create subscription, just always use it, the currently existing. And if that's the case, then it will just skip. And then the first step that we should do before setting up a subscription is to define publication, because publication is the information for Postgres that, hey, for this specific table, do not purge data. And this publication can contain more than one table, and it will group and keep all the information from the specific set of tables that we defined. So it will be like a, I don't know, topic in Kafka. So for example, all the data that we grouped together and we would like to then consume at some point. So create publication is just a simple Postgres statement, which will create publication with the specific publication name for the specific table. We can provide more than one table here, but I'm just, this is a simplified version that uses only a single one. So we will be defining the, we will be saying for Postgres, in our case, that let's create a publication for this specific table. And because of that, Postgres will keep potentially infinitely until we tell it to archive it, all the inserts and all the updates. So all the updates, modification to the table as a append only row by row. Once we have this publication, then once we create it, if it doesn't exist, then we can create a replication slot. And publication will just tell Postgres, hey, don't remove it, keep it. But it won't tell Postgres that it should publish that anywhere. So we need to define a replication slot. And a replication slot is like an entry point, like a port for our Postgres. So we are saying that, okay, besides that you are keeping this data, then I would like to also subscribe to that. So then we are also using some call for this, sorry, not that one. Yeah, so this is function from PostgreSQL, which will create a replication slot for us. So we need to define the slot name. We can also define a snapshot, but let's discuss that later on. So we will tell that, yeah, I told you to keep this data, and this line will tell Postgres, keep it because I want to subscribe to that. Simple. And once we created this subscription, then, as I said, we told Postgres to keep the data from this table, all of the information about the changes that we made. And we said that we will be at some point subscribing to it, but we not yet subscribe to these changes. And subscribing to the changes will be done when we call start replication. And logical replication is a way that Postgres will use a simplified, like a almost readable format. I mean, almost, because it's still binary format, to publish those information somewhere. Because Postgres has two types of replication. Regular, like we know from any other databases, that is focused on the database to database communication. And we also have the logical, which will give us more information, like information about the table, about what has changed. So this logical replication is more suited for application like ours. So when we are doing Postgres to application communication, but Postgres also give us multiple options to format those information. There are multiple also plugins how to get information from logical replication. And one of those plugins, one of the default one, is the PG output, which will replace this binary format into more structured, more readable format for code like this NPGSQL. And NPGSQL will do the stuff or getting information from the PG output. There is also like a test output by default, which we can use in regular SQL IDE to get information like the raw text information via select. There are also plugins like wall2JSON that will make a transformation to the regular JSON. But PG output is a good it's a good trade-off between the performance and the ease of use, especially if we have such libraries like NPGSQL, etc., that are doing that for us. And once we subscribe, so-called replication, then we are subscribing to the slot that we defined. An interesting thing is that for the single slot, we might have multiple subscriptions, and all of the subscriptions will get the same data. So this is really useful because we can also implement more advanced strategies like, for example, competing consumers, etc., or make it more scalable. Of course, potential issue with logical replication is that it's run on server. So we need to be careful to not overwhelm database by the number of subscribers and the amount of data that we are keeping on the server, because the data from the server, like we might eat the whole storage because of that. But nevertheless, we are creating replication slot, so telling database to keep the data, the publication. We are setting up the replication slot to tell database that that we would like to get this data through this specific slot. And here we are saying, okay, then give me the data. So is that clear, or do you have some questions around that? Should I explain that better way? I hope that silence means that it's clear and I didn't lost you. So let's move on. We also, this line is telling Postgres that, hey, I accepted this information, this data that I got from here. So set replication status. This will set up like a subscription checkpoint. Once we subscribe again to these notifications from database, then it will start to read from this specific position of the message that we got the last time. And NPGSQL gives us multiple messages that are implementation of the PG output data. So I'm just using insert message because I'm only interested in new alerts. But if we'd like to, for example, get information that that data was updated or deleted, then we should also add such message support. And we can also get other, like, for example, relation has changed, the truncation happened, index updated, etc. So it not only gives us information about the changes to to the data, but also to the table definition. And there is one more thing, because when we subscribe and when we told Postgres here, hey, create the replication, create the publication, then it will make publication only for the new data, because it's before we told Postgres to keep the data, it was purging the data as any other relational database. But still, we can get the information about the currently existing data, but we might need a bit more. So for that is the snapshot capabilities. So when we are creating the publication, it will return us this, the snapshot, so the snapshot name, and snapshot name will be like a read-only view for our database at a certain point of time. So for example, if we are subscribing to the alerts and we already see here that we have a single, I cleared the database, sorry. But if we, that we already have some information there, then we would like to also get the currently existing data, probably. So then we can use this snapshot, so this read-only view of the current state. That's really important because this will be immutable. So if someone in the meantime deleted or updated record, then we won't see that change, and that change will come later through the subscription. And here I'm just reading the old data from the specific snapshot. So I'm just setting up the specific snapshot, so this read-only view, and selecting all the data from table and one by one publishing those informations. So then, we are also publishing that through async enumerable. And after we read all the existing data, then we are subscribing. And once we get the specific message, so the specific information about the record, then we will do some mapping. Like, for example, I have an event data mapper, or we might have also the flat object mapper, which will by definition try to map the data by convention, etc. So you can use multiple strategies, but what we need to do is to map this insert message into something that is understandable for our application. But getting back to our program, so when we are calling subscribe here, then we are telling that I would like to have the flat object mapper. So just map data as it goes to the specific this alert. And then when we are calling this subscription, then we will be sending the fuel efficiency alert. So just calling the signal R. So pushing this message through the WebSockets directly into our front end. So now let me set up data. And in the meantime, is that flow clear, or how the logical replication works, or should I expand that more?
I have a question. Do all the subscribers have to be online when the message arrives, or can they catch up later?
They can catch up later. So if the service was stopped, then if there is no if there are no subscribers, then Postgres will send messages once they are online. But the one thing that if we put more subscribers into the specific slot, then if one of the subscriber will ACK the specific message, then other subscribers won't get that message again. So if we would like to have a different applications that would be handling those messages differently, then we would need to create more replication slots. So for example, if multiple modules are subscribing for the changes from the specific table, then we would need to have probably different slots. But if we like to make some parallelization, then probably more subscribers into a specific slot. I'm not sure if my answer is clear enough, or should I expand on it?
Does it work like when you have multiple subscribers for the same slot, only one receives it? Or
all will receive them, but let me go here. But sorry, let me find the proper method. Yeah. So this is the critical part. If we didn't have this line, then all subscribers will be getting all the messages as they go. But here we are saying Postgres that I just got this message and do not send this message anymore for me. So we are like defining that this is the last message that I read. Do not give me older than that and this specific message. Just if I subscribe again, then just send me newer messages. So once one of the subscribers ACK this specific message, then no other subscribers will get those older messages. So this is more like a RabbitMQ. If we have a single queue and multiple subscribers, if one subscriber get the message from the queue, then no other subscribers will get it. But here, like all of them are getting that in parallel, but once one of them ACK this message, then no other will get it anymore, including this specific subscriber. So it will mark this message, like this specific position, and all their messages as read.
Okay, I see. And I was wondering if it is working like in Rabbit or and can be used to partition the messages to instances, but I understand now.
Yeah, for partitioning, we would need to define multiple slots, because multiple slot will have their own checkpointing. So that's doable. Both ways are achievable. So if we'd like to partition, then we should use different slots. And if we'd like to parallelize processing, then multiple subscriber for the single slot. We can think about slots as some queues in Rabbit.
Would it be efficient to do people subscribe to parallelize the processing to subscribe with for the same slot? Because if they are all running at the same time, they would catch the same message. And
yeah, I think that I would probably not do it by default. And for most application, the coordination could be much more complex and eat more resources than just running a single subscriber. But because then you would need to, for example, use some like distributed logs. You can use for that like advisory log that I didn't mention, which is super lightweight named log in Postgres, to have only a specific consumer using this specific message. So I would probably not do it as a default choice, but it's good that it's possible. It can be probably done for some failover strategies, like we are sending the same message to all subscribers. And if, for example, the first wins And if then we won't have scenario when, for example, one subscriber dies and we don't have this redundancy. Or, for example, it can be helpful if we are running some Kubernetes environment and we cannot assume that we will have only a single instance, right? Because pod can be automatically started or etc. So potentially this might be helpful, although coordination might be more complex, because and we might get potentially out of order in edge cases, because by default, if we are having single subscriber for a single slot, then we have the ordering guarantee of the message as they were stored. So does that answer your question?
Yes, thank you.
Sorry for it depends, but yeah, my general recommendation would be probably not to try that unless we are some advanced users. Okay, so let me try to start our application. So let's run it. Let's see. Starting. Cool. Looks like it's working. And now keep fingers crossed for the demo gods. I'm starting in the meantime also the React application. Extremely sophisticated. So it's just saying that we have no alerts at the moment. Let me double check if it connected to, let's see. I don't know. There is some error, but I think that's okay. And let's try to do it that way as the grand finale. Fingers crossed. Let's hide it. Let's hide it. Open our console. Delete everything. And put a small insert, which will do some trip that will be like extremely not efficient. Yay! So it went through the database. It went through our .NET application, .NET subscription. And if we add more, then it will append them. See? Voila! It worked when I was doing that on for developers. That it didn't work, but luckily today I was much more successful. Hooray! So as we are going almost, I mean, we are as always over time that I promise you. So let me just get back to the slides if I find them. Yep. So what I wanted to show you, and there was a question about Martin. Is Martin utilizing Postgres for event sourcing? Yes, it does. We are using Postgres as a document database and also around event store. We are not yet using logical replication or sophisticated plugins besides PLV8, which PLV8 is a Chrome JavaScript engine that allows to use JavaScript function and JavaScript language on Postgres. So for example, write stored procedures in JavaScript because why not? Also, there are, for example, Azure for Cosmos DB, so Citus in a nutshell. And Citus is a plugin that allows you to turn Postgres into a coordinated distributed cluster. So it adds the multi-instance coordination and really extremely fast and sophisticated replication strategies, which is very helpful for more advanced multi-tenancy, multi-region strategies. And Microsoft bought Citus and is using that in Azure Postgres for Cosmos DB. And internally, it's using partitioning, etc., with the create distributed table and to replicate that through multiple layers. What's more, there are also other databases like Amazon Aurora, which is using the Postgres engine, but replacing the storage strategies to make it more efficient, more replicable, etc. Because interesting part is that Postgres open sourced their so-called wire protocol, and you can implement based on this protocol any other database that you would like to, and it should be compatible if you use this wire protocol. All the clients are using that. And we also have databases like Neon, which allows to use serverless Postgres. So it's also using the the Postgres engine, but internally it's also using pods, Kubernetes, to have compute nodes that will be doing all the data operations, etc. And we also have databases like Superbase. And Superbase, which is super interesting, is that they manage to run Postgres on WebAssembly, so potentially also in browser. So I hope that you see that Postgres is not only about cheap or zero licensing cost, it's much more. It's super database with the really extremely well built engine. I didn't show you like JSON capabilities, various locking strategies. I only show you a small subset of the capabilities, but I hope that still even this small subset will show you how rich is the Postgres ecosystem and how extremely powerful it is. So because of that, you might not need to write a lot of sophisticated code. You may just try to find whether there is already built-in Postgres. For example, there are also like PG Crypto is super popular for, not for the Bitcoins, but for cryptography. So for example, security around, GDPR, etc. So you can find various plugins that are also available in all cloud providers. And in general, that's all. I hope that you like that webinar and you will try to play with Postgres if you didn't yet. I will also provide the links to some other good resources around Postgres. And yeah, if you have any questions, then I will try to answer them now. So any other questions?
I have some.
Yep.
Would you use the write ahead log in the .NET application like you showed before in the production application instead of just pulling? What I'm considering is that I'm sure that write ahead log is production ready as Postgres uses it, but I'm wondering how, because it isn't that easy on the application side to understand it and to work with it. And I'm thinking when would you use it instead of pulling?
So push notifications can reduce the resources, the amount of used resources, because you don't need to bank constantly your database and potentially DDoSing it. I agree that currently, for example, in a .NET space, the NPG-SQL implementation, as you saw, requires some additional code to write. I'm considering open sourcing the code that I made. It's quite close to be usable, but what I need to do is to play with some fail strategies. So before I'm not sure and haven't found all the edge cases, like for example, what will happen if we restored some older backup, etc. Then I won't be doing that probably. But I think that especially for the notifications like that, I would use it. In Martin, we discussed that with Jeremy, and currently we won't be doing that because potentially batching and pulling, if there is a constant load and a constant predictable usage, then batching may add some more more capabilities on optimization, but batching works well and polling if we have a similar amount of data that is being appended or updated on the specific periods of time. So like the whole day we have a constant load or similar load and we don't have spikes. And if we have more like spikes or not coherent traffic, then subscriptions and push notifications could be much more easier to manage. And especially if those notifications are like those that I show, so front-end notifications that are more hints than like super important usage, like communication between microservices, etc., then I don't think that there is a risk on using that. I can say that, as you noted, the logical replication is production ready. If, for example, there is an open source tool called Debezium, which is used in Kafka Connect for the CDC, and it's pushing for pushing messages. And also all other major CDC solutions are using logical replication to get push notification, because on a bigger scale, it would be and much less predictable traffic. It will be much easier to support. But yeah, it requires some additional knowledge. So before there is like an easy tool to use, proven tool, then I would probably try to use it for something that is less critical, then learn it, and then maybe also for the regular usage, or maybe use tool like Debezium or similar that is already providing some abstractions on top of that. Although Debezium is not so super easy, it has also a lot of fluff around it, so it's not so lightweight to say.
Okay.
What do you think?
That's what I've thought about it. Like for the notification, when you can lose some data or when it will where it wouldn't be critical, it might be a good idea to check it out. I also have
one more thing just to highlight. I would be more afraid about, those operational edge cases, because those subscriptions just work. If there is no weird stuff happening with database, then it will remember, it won't lose any information about the messages, etc. So just to highlight that this is ready.
I was thinking about the code in C# when you would make some mistakes with it.
Yep. So yeah, so I would probably at the moment in .NET I would start with some less critical stuff. And
Okay.
you wanted to ask someone more, right?
Yes. Maybe not connected with your presentation, but with your experience with Postgres and storing JSONs in it. I was wondering how, if you know, maybe some comparison between the index in JSON and typical index. I'm wondering when would you move the data from JSON, copy it to the typical to the column and create index on it instead of creating index on the JSON to query it.
So I don't know exact benchmarks around it. Of what I read is that JSON index, because for others, Postgres has built-in capabilities for type JSONB, and that's what we use in Marten. And we store event data, document data as JSONB. And this type, you can also index some specific property that is inside this JSON. So just a disclaimer. So I didn't do benchmarks and I don't know a precise benchmark because it's super hard, but we were talking with one expert at some point in Postgres, because I'm not expert, I'm just practitioner. And he suggested that better to use by as a default choice if we are using JSONB column than just index on it. And only in the cases when we see that it's not enough, it's not performant, then try to use the generated column as I suggested, as I show, and then try to index on that. We didn't notice yet any, on like a regular scale application, bigger performance degradation if you are querying on the JSONB indexes instead of regular column indexed.
Okay. I was wondering because the project I've seen a lot of generated columns, even if we are storing the whole documents as JSON, but I'm thinking it might be because we are using EF core and it would be harder or maybe even impossible to query by by JSON column.
Yeah, I think that in recent version PostgreSQL team added that also to EF core. But yeah, for sure, comparing to Marten, the EF core capabilities are much more limited. But yeah, I mean, it's also an option. In Marten, we also have duplicate column, which allow to duplicate data from JSON to regular column. But our default recommendation is to just use indexes on JSONB. And we weren't yet proven that it's bad idea and bad recommendation. But if someone has such a benchmark, then I would be happy to know it. I saw, Citelo, that you raised hand. Do you have question?
Yes, it was more in line with your presentation, the subscription there. If I was just thinking, if I want only one subscriber to get the message, but not the other one, I'm sure that is possible from your demo.
Yeah, so there are different strategies. So as I tried to explain earlier, so one slot will keep the checkpoint, so last processed message position in the log for all subscribers. So if you'd like to have multiple subscribers for the same slot, if one will say that I already processed this message, then the other won't. But I think that it will be, for most cases, easier to partition and create multiple replication slot, then if we have a subscriber that will accept this message on one slot, then it won't affect other subscribers, because each replication slot is an information that I would like to subscribe, and it's a separate message. We can think about replication slot as a different port that will stream the same data, but for each different set of subscribers, and use different checkpointing. So is it clearer now, or I should try to explain it a bit better?
No. It's clear. It's clear. So yeah. I've never really played with that part in Postgres. I normally use the Azure Service Bus and things like that.
Mhm.
So I'll try to use that. So I just wanted to know whether
Mhm.
the situation it will address it. Yeah. I'll
Mhm.
try to play with it. If more questions, I'll come back here to you.
Sure.
But thanks a lot. Yeah.
Yeah, sure. So feel free to ask question on Discord. We will try to discuss. I will again on the together with the recording, I will paste some other information. I saw that one company dropped the some messaging system and start to use Postgres for that. I don't recommend to do that immediately, but maybe for simpler systems, that's something that is achievable. And I know that one friend told me that one of the biggest financial application on mobile, I'm not sure if I can say the name, but really popular one, is only using Postgres for the database, for queuing, and it's really big financial application and is capable of doing that. But I don't recommend that as a default choice, because we need to be really skilled on Postgres to do that. I wouldn't feel probably enough skilled to make such decision, at least at that point.
Yeah, true.
But yeah, Postgres is just a superb, powerful database, and extensibility, this plugin options, and the amount of features that Postgres team is adding each release is really impressive. There was just 16 version release.
Yeah.
So yeah, it's super powerful.
Yeah. And where now I work at, we had a presentation, we use AWS. So the company is more into SQL Server, Microsoft SQL Server. So AWS came and yeah, they want us to move into to save cost and move into into Postgres. So they
Yeah.
showed us what was it, Babel fish, something like that. Yeah, that you can still. It looks like SQL on the surface, MS SQL, but you're going into Postgres in the back end. Yeah.
Yeah,
So
I encourage also trying Aurora DB is super
yeah,
data.
yeah. So yeah,
Although,
sorry, I can go for it.
Please continue.
No, I was saying it's strange, the company policy here. They went for MS SQL Server, and it's a common thing. The previous one, they were also into it as well, SQL Server. Even though it's so costly, it was Azure as well. So they were, I don't know why. And if you try to convince them, it's yeah, there's a lot of red tape there, but they are moving because they see the cost that SQL Server, there is a lot of cost. And now when you want to save things, as you say, like JSON binary, SQL Server doesn't support such things. It's kind of difficult to do all those things. Yeah.
Yeah. I also didn't mention, but Postgres is in general easier to use on developers' perspective, because image is super lightweight, and MS SQL image, even this lightweight version, is really big. So even for running integration tests in Martin, we have like thousands of them, and we are able to run it in a few minutes. So most of them are integration. So it's really a
Great.
much easier, much smoother experience.
Great. Yeah, but thanks a lot, Oscar. It's
Thank
winter
you.
this side of the southern hemisphere, but I really appreciate your presentation. Thanks. Yeah.
Thank you. Thank you. One more thing about Aurora is that it might not have those plugins, or maybe just some subset, because
Oh yes. Yeah. I'll try it. I'll try to. I haven't played with Postgres because every command that I go to, they're into SQL Server. So at the end, you're stuck with it.
yeah.
Yeah, but when I saw your presentation saying, "Oh, things on Postgres," I said, "Oh, let me come back." Yeah, thanks.
Oh, Kamil is saying that there is a cablefish, there is a bubblefish, the project that is allowed to migrate data, and it allows to migrate MS SQL to Postgres.
Yeah, I know that one. Yeah, AWS showed us that. Yeah, they came and they showed us, but the company.
Yeah, in general, cloud providers will do all to move the data into them. They will make harder to move out, but that's another story.
Yeah. All right, thanks. Bye, guys. See you next time.
Thank you. Yeah, and Grzegorz and Kamil, any other questions?
I have one more.
Yeah.
How would you use Postgres? I mean, how would you archive or make data cold storage in the Postgres? Would you use the partitioning you showed before, or maybe some other tables, or how would you upload them?
If it was my choice now and I could use partition, then definitely, because it makes stuff really easy. And that's also something that we are planning to add to Marten. So we already have is archived column, and because of that we can partition table based on this is deleted column or is archived, and then just set partition on that. And if you are querying, then you won't be querying, it will be smoother because it won't need to take into the account those soft deleted or archived data. And it's super easy to move this partition outside of Postgres. So I would use partitioning, but if not, then Postgres has also stuff like pgdump, and pgdump allows to do that. Logical replication is also helpful for that. This is potentially a good option to move this data somewhere else, even not to other Postgres, but maybe to some blob storage. And this logical replication sounds like a good fit. But Postgres also have the really powerful binary copy option, which is super fast. But I would probably, first option, if I had that possibility, then I would try to use partitioning. And if I don't have, then I would define something around pgdump, because pgdump is a built-in plugin for backups, and it's super powerful. You can do a lot of stuff with it. And then deleting this data.
Okay, thank you.
Okay. Do you have any other questions?
That's all from me.
Thanks. Good questions. Kamil, anything more from you?
No.
Okay, so thank you guys, folks. Thank you for joining the webinar. For those that are rewatching it, thank you. Feel free to ask questions and send comment on our Discord. And yeah, have a nice day. Have a nice afternoon. Bye.